Welcome to Session 3 of AI Skills and Generative AI Training. We focus on prompt engineering, giving an AI system clear, useful, and responsible instructions. Using examples from alternative protein research, training, communication, policy, and innovation, we will learn to build and improve prompts. The aim is not a magical prompt, but outputs that are easier for experts to review, improve, and verify. By the end of this session, you should be able to explain what a prompt is and why specificity matters. You will learn a 7-part structure covering role, context, task, output format, audience, constraints, and quality criteria. You will adapt prompts for scientists, SMEs, students, policymakers, consumers, and investors. You will also request structured outputs, such as tables, checklists, matrices, and plans. Finally, you will practice improving vague instructions, refining an output through follow-up prompts, and identifying claims that require independent verification. Alternative protein innovation brings together food science, biotechnology, consumer behavior, sustainability, regulation, business development, policy, education, and communication. An AI system does not automatically understand which of these perspectives matters for your task. A weak prompt often produces generic or poorly scoped material with limited practical value. A stronger prompt can produce a clearer structure and a better fit for the intended audience. However, prompt quality does not guarantee factual accuracy. It improves the starting point. Expert review still determines whether the result is trustworthy and useful. A prompt is the instruction we give to an AI tool. It may be a question, a task, a request, or a set of detailed instructions. A useful prompt tells the system what role to adopt, what context to consider, what task to complete, who the audience is, how the answer should be formatted, which constraints apply, and what quality looks like. The central idea is simple. A good prompt is not merely a question. It is a clear description of the work you want the AI to support. Consider the instruction, "Write about alternative proteins." The system does not know the audience, length, protein categories, tone, purpose, or level of detail. It may generate fluent text, but the output will probably be broad and difficult to use. The improved version specifies a role, a 500-word explanation, early-stage APRISE researchers as the audience, 4 protein categories, clear language, and relevant sections. It also says not to invent references and asks for a final list of claims to verify. This does not make the answer true. It makes the output more focused, transparent, and reviewable. AI tools are highly sensitive to the instructions they receive. A better prompt can improve relevance, structure, tone, completeness, and audience adaptation. It can also ask the system to state assumptions and uncertainty. This is especially important in scientific and innovation work, where vague language can hide weak evidence or missing context. The goal is not simply to produce text faster. Good prompting helps us organize information, compare options, ask better questions, and communicate more effectively, while keeping expert judgment and verification at the center of the workflow. A strong prompt usually contains 7 elements. First, role. Who should the AI act as? Second, context. What background does it need? Third, task. What exactly should it do? Fourth, output format. How should the response be organized? Fifth, audience. Who will read or use it? Sixth, constraints. What must it include, avoid, or respect? Seventh, quality criteria. What would make the answer good enough to review and use? You will not always need the same level of detail, but this structure is a reliable checklist for almost any APRISE task. The role tells the AI what perspective to adopt. Act as a fermentation scientist should lead to different priorities and vocabulary from act as a science communication expert. Other useful roles include a food innovation researcher, sustainability analyst, policy advisor, SME innovation consultant, higher education trainer, or consumer behavior researcher. A role is not proof of expertise, and the model does not become a qualified professional. The role simply guides the style, framing, and organization of the response so that it better matches the task. Context explains the situation in which the task will be used. Without context, the AI must guess, and guessed context often produces generic answers. Useful context might state that you are preparing a APRISE training, supporting a European alternative protein project, writing for non-specialist stakeholders, comparing consumer barriers, or mapping industry partners. Include only information needed for the task. Do not paste confidential project data, personal information, or unpublished results into a public AI tool. Good context improves relevance. Safe context also protects privacy and research integrity. The task should be specific and concrete. Write about precision fermentation, leaves the purpose undefined. Better tasks use an action verb and a clear object. Explain precision fermentation to policymakers. Summarize texture challenges in plant-based meat. Create a stakeholder map for algae protein adoption. Or compare consumer barriers across product categories. One well-defined task is usually easier to control than several vague tasks combined. When a project is complex, divide it into smaller prompts and review each result before asking the AI to combine them. Output format tells the AI how to organize the response. Instead of accepting a long block of text, request a format that supports the next step in your work. This could be a 500-word explanation, a table, checklist, training outline, literature matrix, communication plan, stakeholder map, risk register, or briefing note. Also specify useful fields, sections, or columns. A structured output is easier to compare, edit, and verify. Remember that neat formatting can make weak content look convincing, so structure helps review, but never replaces evidence checking. The same topic should be explained differently for different audiences. Scientists need technical accuracy, definitions, methods, and evidence gaps. SMEs often need practical steps, costs, resources, and implementation risks. Students benefit from simple explanations, examples, and learning activities. Policymakers need neutral language, trade-offs, and regulatory relevance. Consumers need plain language and transparent answers without hype. Investors need market maturity, risks, milestones, and due diligence questions. Defining the audience helps the system choose an appropriate depth and tone. It also helps you judge whether the result is actually fit for purpose. Constraints establish boundaries. They may require clear language, neutral tone, a maximum length, regulatory considerations, or an explicit discussion of uncertainty. They may also prohibit technical jargon, hype, unsupported claims, or invented statistics. In research and policy contexts, useful constraints include distinguishing evidence from inference and identifying statements that need verification. Constraints cannot guarantee compliance, so inspect the output carefully. Think of them as guardrails that reduce avoidable errors and make the expected standard visible to both the AI system and the human reviewer. Quality criteria define what a good answer should look like. Depending on the task, you may ask for an accurate, balanced, and decision-relevant response that is clear to non-specialists and easy to reuse. You may require the output to separate facts from assumptions, identify knowledge gaps, avoid exaggeration, and show uncertainty. Criteria should be observable. Make it excellent gives little guidance. Compare 3 options using the same 5 criteria and flag missing evidence is much clearer. Quality criteria also provide a practical checklist for human review after generation. This reusable template combines the 7 elements into 3 working groups. Start with persona and delivery. Define the role, audience, and output format. Then write the core message. Provide the project or task context, name the topic and purpose, and give one concrete instruction. Finally, add guardrails. Require clear language, important assumptions, a distinction between evidence and inference, and no hype or unsupported claims. Add regulatory, safety, or sustainability considerations when relevant. Finish with quality criteria, stating that the results should be accurate, balanced, structured, and usable by the target audience. Copy this framework and adapt it, rather than starting from a blank page each time. In the first example, the role is a food policy analyst, and the audience is policymakers without specialist biotechnology knowledge. The task is to explain precision fermentation in 400 to 500 words. The requested structure covers what it is, how it differs from traditional fermentation, possible public interest opportunities, and key regulatory aspects. The guardrails require plain language, a familiar analogy, no hype, and attention to safety and labeling. Notice how each instruction serves the audience. The final briefing must still be checked against current official regulatory sources before use. Here, the AI is asked to adopt the perspective of a food structure and sensory researcher. The audience is early-stage researchers, and the task is a focused summary of scientific and technological challenges in meat-like texture. A 4-column table makes comparison easier. Challenge, why it matters, common technical approaches, and unresolved questions. The scope includes fibrousness, juiciness, fat distribution, binders, processing, and sensory validation. The prompt also asks the model to distinguish established knowledge from emerging research areas. Any specific scientific claim or method must then be verified in the original literature. The third example supports project and policy engagement. The role is an innovation and stakeholder engagement specialist. The context is algae protein adoption in Europe, and the audience is project managers and policy teams. The output is a matrix covering stakeholder group, interest and influence, likely concerns and motivations, and a suggested engagement approach. The scope includes producers, researchers, regulators, manufacturers, retailers, investors, non-governmental organizations, and consumers. This structure helps organize thinking, but stakeholder positions should be confirmed through evidence and direct engagement, rather than assumed from an AI-generated map. This example uses AI to support instructional design. The role is a higher education trainer in sustainable food systems. The audience is a graduate-level group from mixed disciplines, and the task is a 20-minute activity for APRISE participants. The output must include a learning objective, materials, step-by-step procedure, debrief questions, and expected learning outcomes. The activity covers plant-based, fermentation-derived, cultivated, and algae proteins, and must work without laboratory equipment. The trainer still checks scientific accuracy, workload, accessibility, and whether the activity genuinely supports the stated learning objective. The fifth example compares consumer barriers for cultivated meat and plant-based meat. The role is a consumer behavior researcher, and the audience includes researchers, industry participants, and communicators. The requested output is a comparison table, followed by a short synthesis. The prompt names relevant dimensions: naturalness, taste, texture, price, trust, safety perceptions, familiarity, and information gaps. It also asks which barriers are shared and which are category-specific. This focused comparison becomes the basis of the practical activity later in the session. Evidence should come from verified studies, not from the model's memory alone. The final example maps types of potential industry partners. The role is an innovation ecosystem analyst, and the audience is project coordinators and business engagement teams. The table asks what each partner type could contribute: a possible collaboration goal, and screening questions. The scope includes ingredient suppliers, fermentation firms, pilot facilities, sensory testing partners, regulatory consultants, packaging firms, retailers, and sustainability or LCA specialists. A crucial constraint says not to invent named companies unless clearly labeled as examples. Real partner selection requires current research, due diligence, and direct confirmation of capacity and interest. Prompts for scientists should define the inquiry's boundaries, methods, variables, terminology, and evidence standard. They should also request limitations, uncertainty, and research gaps. The example asks for a literature matrix on protein functionality in plant-based meat analogs, with fields for protein source, method, findings, limitations, and open questions. It also asks the model to distinguish peer-reviewed evidence from assumptions or emerging hypotheses. Use AI to organize supplied sources or design a matrix, but verify citations and extract findings from the original papers, rather than trusting generated references. SME audiences usually need practical, action-oriented outputs. Useful prompts emphasize costs, resources, implementation barriers, market opportunities, partnership needs, regulation, and near-term decisions. In the example, a small food company is exploring algae protein as a new ingredient. The AI is asked for a checklist covering technical, regulatory, supply chain, consumer acceptance, and communication considerations. This creates a useful agenda for expert discussion. It is not a business case or regulatory approval. Current costs, supplier capacity, legal requirements, and technical feasibility must be confirmed independently. For students, specify the starting level, learning objective, vocabulary, and type of practice. The example asks a university teacher to explain 4 alternative protein categories to first-year food science students. It requires simple language, 1 example for each category, and 3 reflection questions. This is more useful than merely asking for an easy explanation, because it defines both content and learning design. The instructor should still check accuracy, avoid oversimplification, and ensure that examples are inclusive and relevant. AI-generated teaching material also needs accessibility and copyright review before distribution. Policymakers need neutral, concise, and public interest-oriented information. A useful prompt should request policy options, risks and benefits, regulatory context, stakeholder implications, and trade-offs. The example asks for a 1-page briefing on alternative proteins for regional policymakers. It includes innovation opportunities and areas where evidence remains uncertain, while explicitly avoiding promotional language. The prompt can improve balance and structure, but the final briefing must use current official sources and clearly separate scientific evidence, policy interpretation, and stakeholder positions. AI should assist drafting, not define public policy. Consumer-facing prompts should prioritize plain language, transparency, and practical relevance. The example asks a science communicator to explain cultivated meat without technical jargon or hype. It covers what the product is, how it is produced in general terms, why people may be interested, and what reasonable questions consumers may ask about safety, taste, and regulation. Good communication does not mean persuading the audience. It means providing an accurate and balanced explanation. Avoid universal claims, disclose uncertainty, and check all safety or approval statements against the relevant authorities. Investor prompts should address opportunity and risk together. Useful dimensions include technology readiness, competitive landscape, regulatory barriers, scale-up challenges, business model, milestones, partnerships, and due diligence questions. The example requests a structured overview of precision fermentation ingredients in Europe and explicitly rejects exaggerated claims. An AI-generated overview may help identify topics for investigation, but it is not investment advice and may contain outdated market information. Financial, technical, regulatory, and intellectual property claims require current specialist verification before any decision is made. Prompting is usually iterative. The first answer is a draft that reveals what is missing, unclear, or poorly structured. Follow-up prompts can request a clearer explanation, a different audience, a table, a shorter format, or a section on regulatory uncertainty. They can also challenge assumptions and ask for a list of claims requiring verification. Make one meaningful change at a time so you can see its effect. Keep the original prompt and each revision. This creates a traceable record and helps you learn which instructions improve the result, rather than simply producing more text. An AI system can critique its own answer by suggesting weaknesses, assumptions, missing perspectives, or questions a skeptical reviewer might raise. This can be a valuable revision aid. It is not independent verification because the critique comes from the same type of system that produced the original response. Ask questions such as, what did you assume? Which perspectives are missing? Which claims need checking? How could this be more balanced? Then use those questions to guide human review. Treat self-critique as a way to expose possible blind spots, not as proof that the answer is correct. AI can help prepare verification by extracting factual claims, separating established points from uncertain ones, flagging potentially outdated statements, and suggesting search terms. It can also build a checklist showing which claims need peer-reviewed evidence or official regulatory sources. But the model cannot verify itself merely by saying that it has checked. Independent verification requires leaving the generated answer and consulting the original paper, official authority, current database, or qualified expert. Record the source, date, and relevant passage. The correct principle is, use prompts to organize the verification task. Use external evidence to complete it. Tables are useful when the same criteria must be applied across several categories. The example compares plant-based, fermentation-derived, cultivated, and algae proteins using production method, opportunities, challenges, sustainability, consumer acceptance, and regulation. Naming the columns prevents the answer from drifting into unrelated detail. Keep cells concise and add a source or verification column when factual claims are involved. A table makes gaps and inconsistencies easier to see, but every row still needs critical review. Checklists support planning and quality control. Here, the prompt asks for a checklist to review an AI-generated briefing before sharing it with APRISE partners. The checks cover accuracy, balance, audience fit, unsupported claims, regulatory sensitivity, sustainability claims, and clarity. A checklist turns general responsibility into observable actions. It should identify who checks each item and what evidence is acceptable. Do not let a completed box create false confidence. The review is only as strong as the evidence examined. Training outlines help organize learning into a coherent sequence. The example requests a 45-minute session on consumer acceptance, including objectives, timing, key concepts, activity instructions, discussion questions, and expected outputs. This gives the trainer a usable first structure. Human review should then confirm that the timing is realistic, activities serve the objectives, and the content matches participants' prior knowledge. Accessibility, cultural relevance, and evidence quality must also be checked before the outline becomes teaching material. Literature matrices make studies easier to compare. The example requests columns for author, year, country, method, sample, findings, limitations, relevance to APRISE, and follow-up questions. The essential constraint is do not invent papers. The safest workflow is to supply verified articles or bibliographic records and ask the AI to organize only that material. Then compare every extracted field with the original paper. A matrix supports synthesis. It does not replace reading, appraisal, or correct citation. Communication plans connect audiences, messages, and channels. The example asks for a plan explaining algae proteins to regional stakeholders. It includes audience segments, message pillars, communication channels, likely concerns, recommended tone, and risks to avoid. This structure helps teams see where one message may not fit every audience. Before use, check the evidence behind each message. Avoid overstating benefits, and confirm that the chosen channels are appropriate and accessible. Communication should build understanding, not manufacture certainty. Risk registers support innovation and project management. The example requests risk description, category, likelihood, impact, mitigation, owner, and early warning indicator for a fermentation-derived ingredient pilot. It covers technical, regulatory, supply chain, consumer, and communication risks. AI can propose an initial structure and possible categories, but it cannot know the project's real probability, impact, or ownership without validated information. The project team must review, score, and update every risk using current evidence and accountable decision-making. The first common mistake is vagueness. Tell me about plant-based meat. Gives no audience, purpose, format, scope, or quality criteria. A better prompt asks a food technology trainer to explain specific technical challenges for early-stage researchers, using a table that covers texture, flavor, nutrition, processing, cost, and consumer acceptance. It also asks for uncertainty where evidence is developing. The improved prompt is still compact, but every added detail helps shape a result that can be reviewed and used. Specificity is not about length, it is about relevant information. The second mistake is combining too many goals in one request. Asking for a complete report on technology, regulation, sustainability, investment, consumers, policy, and training will probably produce superficial coverage. Divide the work into smaller prompts. A regulatory overview, sustainability comparison, consumer acceptance summary, investor briefing, and training outline. Review each output, correct its scope, and verify the evidence before combining the parts. This staged approach reduces hidden omissions and makes responsibility clearer. Complex work is usually better managed as a sequence than as one enormous prompt. The third mistake is omitting the audience. Explain cultivated meat could produce language that is too technical, too simple, too promotional, or too long. The needs of food science students, policymakers, consumers, investors, and SMEs are different. Name the audience, and when useful, state its existing knowledge and purpose. This helps control depth, terminology, and tone. After generation, test the result against the intended audience. Can they understand it, use it, and identify uncertainty? Audience fit must be evaluated, not assumed. The fourth mistake is asking a leading question with no evidence standard. Why are alternative proteins sustainable? Assumes the conclusion and may encourage a one-sided answer. A better prompt asks for arguments both for and against, distinguishes established evidence from context-dependent and uncertain claims, covers several protein categories, and avoids universal statements. This does not remove bias automatically, but it makes balance and uncertainty explicit. The reviewer must still check system boundaries, comparison baselines, geography, energy sources, and study quality before accepting any sustainability claim. The fifth mistake is ending the process when the AI produces a fluent answer. A briefing on precision fermentation may contain factual errors, invented references, or outdated regulatory information. Improve the prompt by requiring a final section called Claims to Verify, covering factual, regulatory, and market statements that need official or peer-reviewed evidence. This list is a review aid, not a guarantee that every problem has been found. A human reviewer should also identify missing claims, open the original sources, confirm publication dates, and record what was checked before publication.
The sixth mistake is hidden advocacy. Convince consumers that cultivated meat is the future presupposes a positive conclusion and encourages promotional content. A better prompt requests a balanced explanation, covering potential benefits, common concerns, safety and regulatory questions, and areas where evidence or market experience remains limited. It also requires neutral language. In scientific communication, credibility matters more than persuasion. Review the final text for loaded terms, omitted perspectives, and unsupported certainty, especially when communicating with the public. Now apply the method to this weak prompt. Compare consumer barriers for alternative proteins. The practical activity lasts 18 minutes in total. Begin with layer 1 and define success before writing the full prompt. Spend about 8 minutes identifying the audience, purpose, success criteria, and verification requirement. For this exercise, the audience is APRISE researchers, industry participants, and communicators. The purpose is a project workshop. Success means balanced coverage and explicit uncertainty. The output must include a visible claims to verify section. Pause here, write your short layer 1 brief, and continue when it is ready. For layer 2, convert the brief into a complete prompt and test it. Use the role of consumer behavior researcher. State that the context is an APRISE workshop on market adoption. Ask for a comparison of barriers affecting cultivated meat and plant-based meat for researchers, industry participants, and communicators. Request a table plus a 120-word synthesis. Cover naturalness, taste, texture, price, trust, safety perceptions, familiarity, and information gaps. Prohibit invented statistics and sources. Require shared and category-specific barriers, explicit uncertainty, and a final claims to verify section. Spend about 10 minutes running, reviewing, and refining the result. Before using a prompt, complete this final checklist. Is the task clear? Is the audience explicit? Is the scope narrow enough? Is the output format useful? Are the constraints visible? Then check reliability. Are factual claims limited to supplied or verified sources? Have you stated quality criteria? Is there a real verification step outside the AI system? Is the output suitable for scientific or innovation use? A good prompt does not eliminate review. It makes the output easier to inspect, reuse, and improve, and it makes responsibility easier to see. 3 ideas summarize this session. First, prompt engineering is the skill of giving AI clear, useful, and responsible instructions. Second, strong prompts define role, context, task, format, audience, constraints, and quality criteria. Third, AI should support expert thinking, not replace expert judgment. In APRISE, these practices can improve research synthesis templates, learning materials, stakeholder and risk mapping, neutral policy briefings, and communication for varied audiences. The value comes from combining better instructions with careful human review and external evidence. Before finishing, connect the method to your own APRISE role. Choose one task in research, training, project management, collaboration, policy analysis, regulation, dissemination, or sustainability communication. Write down where AI might support that task this week. Then draft one improved prompt using the structure from this session. Keep the task small enough to test, define what success looks like, and decide which claims or decisions will need human or external verification. This reflection becomes a practical starting point for the next sessions. You have completed Session 3 on prompt engineering. Remember, be specific, define the audience, request a useful structure, set clear constraints, and plan independent verification. AI supports the work. Humans remain responsible for the final judgment. Complete the Session 3 quiz using the link or QR code on screen. In the next session, we will examine how AI can responsibly support literature reviews in alternative protein research. Thank you for participating, and keep your improved prompt for use in the next practical activities.